Hey, what's up guys, my name is Cherno. Welcome back to my game engine series. So today we're going to be taking a look, more of like an introductory look at an EnTT component system and how we can basically integrate that into our game engine and what the big picture of that is going to look like. If you don't know what an EnTT component system is, then please watch last week's video where I actually just drew a diagram and we talked about what EnTT component systems were, why we want them, why they're better than just doing things a different way. I think that's really going to help you understand why we're going down this route at all. I mean, there's a lot to say there, so just watch that video first and then this will make a lot more sense. So what we're going to be doing today specifically is we're going to be taking a look at an EnTT component system called EnTT or ENT. This is an EnTT component system that has been around for a while. It's used by a few major projects. You can actually look at the GitHub repository linked in the description below to take a look at what that's all about. I've chosen to use an EnTT component system that is not something that I've written from scratch for a few reasons, and I've talked about those reasons in prior videos. But to keep it short, the reason is because an EnTT component system is, or at least a good EnTT component system, is something that's largely complicated and it will take a long time to write properly. I know this from experience, and it's not really something. I mean, you can write a very basic EnTT component system probably in a week or maybe a few days or however many hours you want to spend on it. But I've chosen to take something else for Hazel because, first of all, I don't really like. I know that an EnTT component system is something that is like we need to have a good one for Hazel. That's just like there's no way around it because otherwise we're going to be quite limited with how we use entities. And my ideas for how we're going to be using entities and components means that we really need to have a good EnTT component system. But also because out of all the things that I'm interested in, EnTT component systems are not, at the moment at least, not my biggest focus. I'm really interested in graphics and rendering and all of that stuff, which is why we're doing that stuff ourselves. But an EnTT component system is not like my highest priority, and of course, as pretty much a one-man show writing this engine, it would be very unrealistic for me to dive deep into every component that makes up a game engine. So maybe in the future, if people want, and if that's like a thing that I get around to, I might make a tutorial series on just writing an EnTT component system standalone, just so that you people understand better how they're put together, and that might be a fun little educational thing, but I just know that ENT's going to be better than anything I'm going to write in the next few episodes if I spend that amount of time on it, and it's just a really good proven EnTT component system, so I don't see any reason for why we shouldn't use it. Speaking of which, let's take a look at it. So this is ENT. I'll have a link in the description below to the GitHub page here. You can see that it is MIT licensed, which basically means that we need to disclose that we're using it, which is totally fine. So license and copyright notice is basically the condition here. There's, I mean, it's used by Minecraft. I think the Windows 10 edition. It's quite proven, and it's also quite simple. I've been using it in Hazel Dev for quite a while now. For those of you who don't know, Hazel Dev is like the Patreon only kind of version of Hazel that is like pretty much a full game engine at this point. That's been using ENT for a while, or EnTT for a while. Just to be clear, I know that I think it's technically supposed to be pronounced EnTT, but I'm going to call it ENT. And the reason I'm going to call it ENT is just because it's a little bit ambiguous. If I say the word entity, it's like you might not know what I'm talking about. I might be talking about the entities in the EnTT component system, or I might be talking about this library. So in the future, I'll just say ENT for this library, and that way it'll be less ambiguous. Anyway, I suggest that you read the wiki if you're new to this. If you've never used ENT before, read the wiki, because if you specifically read the crash course of the core functionalities, this, and there's a lot of you should read this whole thing really, but this stuff will kind of, it's not even this, I think there's another, maybe it's this, EnTT component system. Yeah, this is what I'm talking about. If you read this actually explains a few of the design decisions, pay per use, meaning that you don't have to, as I mentioned, I think last time, things that you don't use, even though it's a very big library, things that you don't use aren't necessarily going to cost you in terms of performance. There's so much stuff going on here. You should read through this whole thing. This was basically my first point of contact with a library. It's written quite well, and it has a lot of really nice examples. So if you read this, you're going to be very familiar with this, and everything that I want to say in this video is probably not going to be completely redundant, maybe, because I'm going to talk about how it's going to work in Hazel, but it's going to be, you're going to know a lot. So all we really need from this, we could get this library as a submodule and add that, and you can see it gets updated fairly recently, fairly frequently. Like this was yesterday. You know, the single header file was updated 2 months ago. I believe that it probably gets updated with like releases and stuff like that. My favorite way to use a library like this, because there's a lot of stuff here, there's a lot of stuff that we don't care about, is to simply take the single include. So we have a single include here, which is the ENT file. Now, I don't know if this has the license inside it. No, it doesn't. So we'll need to obviously take the license as well. So this is the license. So what I'm going to do is basically grab this ent.hpp file. And if you click on raw over here, you'll just get the file, right? And then you can save that as. And we're going to put this into, if I go back to Hazel and open the Hazel folder in the File Explorer, and if I go into vendor, and then I'll make a folder called ent, I'm just going to pop that into there. So let's copy this path, pop it over here, and here we go. We'll save it as just ent.hpp. Okay, that's it. And in fact, I'll make a folder here called include, and I'll put it into there. That way we can just include that directory. And we should be good. The reason is we also need to include the license files I mentioned, and the license file and the copyright notice and all that stuff. I don't know if the license file is included in that, probably not. There's well, I don't really see the copyright notice anywhere. Maybe just the license is fine. So if we grab this license file, save it in the same folder, or rather up here, I'll just leave it as a text file because that makes sense. That's it. Right, so this includes the copyright, that's it, okay? So that's all we really need to kind of use ENT. It's really just this file. It's really easy. That's the beauty of these single kind of file includes, and it's going to enable us to have an entity component system in our engine. Now, how do we set this up? Well, a few different ways. What I'm going to do is I'm going to go back up to the root directory, and I'm going to open the premake file, and inside the premake file, I'm going to add a directory up here because we tend to keep them up here because it's just a little bit more it's a little bit better organized if we keep them here. I'm going to type in entity like this. In terms of like how we want this, I'm going to put this last just because like all of this is pretty much to do with graphics and windowing and stuff, whereas this is like the entity component system. I haven't given much thought to this clearly. I'm doing all this live, so it doesn't, like whatever. Maybe I'll change it. And we'll just do ent include, okay? And then if we go down to, and you can treat this however you like. You can put it into a folder called ent inside include. So you do ent/include when you do ent/ent.hpp. That's your include path. When you write code, I'm going to leave it as is, honestly. And then in the include directories, we're going to have to do two things. We're actually going to have to include it in the engine like this, right? But we're also going to have to include it in the sandbox and in Hazelnut as well. The reason is, it's kind of like for the same reason as GLM maybe. The reason is that, and again, it's whether or not you 100% need to do this, I can't tell you. Well, the answer is no, you don't 100% have to do this, but if you choose not to include ent in your client source files, then things become very difficult because ent is a header library, or rather a templated library. So by saying that you don't want to include it in the client, you're saying that much of the library's templated features cannot be used by the client. Because obviously, if you're only including it in the Hazel library, then only code that only code that uses those templates from ent inside the actual Hazel library, that is the only code that will be compiled from ent. Which means that if I come in from the client, from my game or from my editor and decide to add a component or get a component or create a new component or something like that, I can't do any of that. Because to get a component from ent, I have to have a function to link to. And if that's never been done in the engine, for example, then that function will simply never be compiled and it won't exist and nothing's going to work. So by including ent in here, we're basically saying that even though we're never going, ideally we would never interact with ent directly. I don't want to be using the ent API from my game. we should be going through Hazel for that for a number of reasons, mostly because we might be doing extra stuff on top of Ent that relies on those proper functions being called rather than internal functions, which is what Ent is going to be. But largely, this is kind of this enables us to use the full power of Ent through wrappers and other things without having to worry about what has been compiled, what has been used, what templates have been instantiated and which have not. So that's kind of the reason for having that in here. Now, that's probably it. Let's try and compile. Let's try and run that pre-make file, and then we're going to see if that helps. And by helps, I mean if we get so in editor layer, we should already have access to this. Now, I don't think we have scene or an entity class. We're going to create a scene class here. If we go into core, we're actually going to make a new folder inside Hazel. I'll make sure that show all files is checked. And I'm going to make a new folder here called scene. Now, this is going to contain everything to do with scenes, entity component systems, components, all of that stuff, right? Entities, everything will be inside this scene folder. So this is not just going to be the scene, it's going to be like all the ECS stuff as well. So inside this scene, namespace Hazel, class scene, this will be something that is, well, it'll be reference counted, but that's not really necessary to talk about now because we're not really doing that. HZPCH and scene, just some boilerplate code here. Okay, so we've got our scene class. I'm going to basically use this scene class to talk a little bit about how Ent is going to work. And to be honest, it's very, very simple. There's not even that much to talk about, but this is going to function as kind of an introductory video. This is just going to be a little bit of an introduction to Ent in general. So if we go back out here, when we create a scene, I'll have just a default constructor and a destructor as well, which we will fill up with a few different things. And then ultimately what we want here, and we'll include Ent over here. This is another reason why we need to include it in the client, because we're going to be including Ent in the header file. And really what we want to be using is something called the registry. Now the registry is basically a container for all of these components and entities. So entities, the way that entities work are entities are simply IDs, as I mentioned in the kind of what an entity component system is and all that in the previous video. An entity is basically an identifier that we use to determine which components kind of belong together in the entity. And a registry contains the actual component data as well as the entity IDs. That's what a registry is. There's a few other things going on there as well, but that's basically all you need to know. Now, inside this registry, so picture the registry as like our entity context. It's the container that contains our entities, even though entities by themselves don't really contain much data. But that is what the registry is. So in other words, the way that I like to do this is to just to have a registry per scene. Now, if you need to, have an entity persist from one scene to the other, you can copy the entity into there. I know that Ent has some like serialization snapshot mechanics. I haven't actually been using them. I basically just rolled my own and in Hazel Dev. And the reason for that is because honestly, I like reading the documentation, I just could not, like I spent about 10 minutes on it and I was like, no, this doesn't make sense to me. Like, I don't know how this works. There aren't any clear examples. I'm not even sure if this is the right path. So I just decided, whatever. At that point in Hazel Dev's like development, I just wanted this thing up and running and serializing as soon as possible. So I didn't really care too much about that, but I know it has that. So if you guys want to do more research and figure out whether or not that's something we should be using, then be my guest. But for now, I haven't done that. So registries, like lots of features there. I think there's even like a signaling system with events. So for example, you can cache events when components get created or removed from entities, and you can process them that way. There's a lot of stuff going on. So just keep that in mind. So that's the registry, and that's the basis for all of our kind of entities in our scene. So if I create this stuff, we'll do a little bit of a test here, as I mentioned. So upon destruction, the registry will be destroyed and everything will get released, but we don't have to worry about that because it's a stack allocated registry object here, so it'll just get cleaned up automatically. So what I'm interested in is how do we add stuff? Well, it's pretty simple. We just do registry create. What this does is it creates an entity, and we have an entity type that it returns. So there's a few different functions here, but basically we can just literally do this, and I think this will return an ent entity, right? And this will be our entity. So we've created an entity inside ent. Great. So what is entity? And this is, again, important to understand, I think. If we look at what entity is an opaque type. Well, I don't even know what this macro does. Enum class type, blah, blah, blah. This is probably not what I wanted to look at. Here it is. So enum class entity ID type, and then you can see the type here is an ent ID type, and the ID type is an unsigned int, a 32-bit unsigned int. Okay, so that is what an entity is, right? It's called an entity, right? But ultimately, it's this. This is what we're dealing with if we were to break this down, and we can actually cast between them if we want. But that's basically it, okay? So again, understand that. And because of that, you can't do things like entity dot whatever because it's an integer. Instead, everything goes through the registry. So in other words, if I want to suddenly add a component to it, I just do registry dot, I think you can do insert. There's a few different ways. Insert. And honestly, like, I'm just going to reference some Hazel Dev code because it's been a while since I actually used Ents API because I have my own wrapper. In place. So in place is what we've been using. In place, and then we obviously specify the actual name of the component, the entity that we're placing into, and then any constructor arguments. So let's just say we have a transform component. How do we define components? Like this. That's it. It's just a struct. There's no inheritance. Like, it's not like there's like a base class that we're inheriting from. None of that whatsoever, because we don't want any of that. That's just extra noise. What we want is basically a structure of data. That's our component data. So transform component would have a glm mat4. You could use glm mat4 itself, but that's a little bit messy. It doesn't say that it's a transform component. You could define different types. There's a billion ways you could do this. You honestly could do it that way. I don't like to do it that way. I like to define a component called transform component, which has data inside it. So let's include glm. This is what we have here, okay? A transform component. A mesh component would be the same thing. It would have mesh. Now you should probably make sure that you have a copy constructor, maybe a default constructor as well. So I would have a default constructor. I'd have a constructor that, we'd have a copy constructor that kind of is just a shallow copy. I don't even think we need this. We might need this. We could probably leave this as default though. Like that, is that a thing? Yes, it is. I need to brush up on my C++ clearly. Transform component const glm mat4 transform, and then this obviously is just going to set transform to transform. So this is like basically a little tutorial of how to write a component class, right? And then destructor, obviously we have a default one. We don't care about that. So copying components, in my experience, I've used that a little bit in Hazel Dev. I think it's a good idea to have. And then finally, what you could do if you really wanted to is basically, there are a lot of scenarios in which you might want to use the transform component as a matrix, for example. So what I mean is, like, maybe we have static void do maths, and then yes, I'm Australian, so I have the S in the end, sue me. So we have const glm mat4 transform, right? And then obviously this is going to do something with the transform. Now, if we want to call this function, it's a little bit annoying if you have a transform component. So maybe this is your transform, whatever. And then you want to call that. And by the way, just about that little joke, when I write code, I typically do actually write it in American. So you might see me use color, for example, instead of that, even though if I was writing a Word document or some kind of handwritten note to someone, I would write color like that. So when I write code, I almost always write this like this. So you'll never see me write this, which is why it's not even realistic. It's not even a realistic joke. So for that, I apologize. So if we're doing some kind of math here, then it's really nice for me to be able to provide a transform like that. It's kind of annoying in my experience to write code like this, which is the only way that this will compile at this point. So what I tend to do, which some people might frown upon, is I basically have an operator that is my operator glm mat4, right? And by doing this and returning the transform, of course, right? What this does, and you can do whatever you want with this. Whatever, right? The point is this will return your transform, which means that suddenly instead of doing this, I can actually write code like that, right? Because I've written, this is like an implicit cast operator. I have no idea what it's actually called, but that's basically what it is. It just lets you implicitly do that cast. And in fact, it probably lets you do it explicitly, because I don't think that this will compile. If I do glm mat4 transform, maybe it will. Oh, whoops, I've got this. Yeah, I didn't expect that to work, because that's not, like, obviously you could type on it, where you basically, you know, do this, and that will in fact work. But that's obviously very messy, and some people will really frown upon that. So what I like to do is add an operator like this to my components, just so that, you know, it's just so that I don't need that extra kind of level of interaction, like in terms of my code. I actually can just write code like this, and it will work, because anything that accepts because since a transform component really is just a mat4 wrapped in this transform component type, it's essentially, you know, you can use it in every way imaginable where you can use a mat4, a glm mat4. So I like to do that conversion just because it cleans up the code a little bit. So just keep that in mind. And you can obviously add, this is like a const version. You can obviously add a non-const version as well, like this. And Visual Studio likes to correct it like this. All right. And sorry, I meant that. Whoops, sorry, microphone. There, okay, so now you have a non-const and a const version. You can do whatever you want with that. So that is kind of how I roll as far as all of that stuff goes. Great, so how do we get that into the entity? Well, it's pretty easy. As I said, registry in place, we put in the type, transform component. This is created on the fly. You don't need to register your components ahead of time, which I find is really, really nice and one of Ent's great features. Then we provide the entity where we want to basically place the component into, so what entity does this component belong to. Then we provide the arguments, right? So in other words, you know, you don't have to do anything. That's going to just use the default constructor, but you can also provide your glm mat4 transform here. So I can do glm mat4 for the identity matrix, and that's it. I've in placed a component. It's inside my entity now. And it's a transform component, which is initialized to the identity matrix, okay? So that's done. That's really all you have to do. Now, you know, removing components, you know, there's registry remove. Remove, as you can see, will remove any, like a list of components from an entity. So you can do like transform component entity like that. It's going to remove it from the entity. There's registry. I think you can clear the registry, which is just going to remove everything. I think you can, what else is useful? Registry, oh, get, of course. So I want to retrieve the component now. I have my entity. This is my entity, right? Pretend this doesn't exist, this transform component. Well, I mean, it doesn't. There's no way, I think, in place. Okay, in place returns it. A few different things going on here. So you can actually, when you in place it, you can also return, it also returns it. So you can immediately start writing to it. So I can say transform equals glm mat4 something else, right? And now I'm changing the matrix. So that's something that you can do. If it was like a mesh, you can, you know, do something to the mesh, like get its materials, whatever. You guys get the point. It returns a reference to it, which you can do whatever you want with. However, if you're in a different function, you just have the entity. How do you get my entity's transform? You just say get transform component and then entity, and that's it. So this will return a reference to the transform component. So now you have, I'll just write the type so we're more clear. Now you have a reference to the transform component. You can reassign it. You can reassign the transform within it. You can do whatever you want. You have that reference. Now, how do you know if it has a transform component? You can do registry.has transform component, again, passing in the entity, and then that's only going to trigger if it actually has that component. And then finally, one thing that's particularly useful is not just checking to see if a particular entity has a component, because this is all kind of doesn't really need an entity component system, but the big juicy part of this entity component system, which is why we want one in the first place, is what if I want to iterate through all of my entities that have transform components? So to do that, there's a lot of different ways. Honestly, there are so many different ways. The best one probably, I think, is to use a view. Now a view, and there's also a runtime view, which is based on runtime type. So if you don't know the type at compile time, so in other words, you can't use templates, then you can use a runtime view, but I've never had to use that yet. So you just do registry view transform component, and that's it. This gives you a view that you just use like this, and then you can actually iterate through all of the entities in that view. So this view consists of all these different entities. So now I have an iterator going through all of the entities in my scene, in my registry, that contain a transform component. So here's a scenario. I want to render all of my meshes. You do this with your mesh component, and then you get a view of all of the entities that actually contain mesh components, and you just render them. Simple as that. So in other words, if I actually wanted to get it out here, I would basically just do the same thing here, where I do transform component transform, and then I have my actual entity here, okay? Simple as that. That's how that works. Now, what if you want multiple components? So going back to my mesh component example, we need more than just the mesh component to render a mesh. Usually we also want the transform component. So to do that, you can use a group. So auto group equals registry.group, and this lets you group multiple components. So basically you just do transform component, and then in here, and I'm going to pretend that I remember this, but I don't. So everything's falling apart now, and I'm looking at Hazel Dev code to see how exactly I've been using groups. Okay, get. I was close. Get mesh component. Now we don't have a mesh component, so I'll quickly add it. Struct mesh component. Oh, we don't even have meshes, do we? This is a 2D engine. Whatever. It could be a sprite. That's it, right? So you basically, once you have that, then you can, and I think with view, yeah, okay. I think you might be able to, there's also a view get function, by the way, which I think does the same thing. So you can actually do this. Does this work? Yeah. So you can do this instead of getting it from the registry, which I suspect is the proper way to do it, just because it's probably more optimized since you're only dealing with this current kind of narrow view, not the whole registry. But realistically, I have no idea what I'm talking about, but I can't imagine it being much better because of the way that Ent is built anyway. And then, yeah, for the group, we basically just iterate through the group the same way as a view. So we go through the group here, and then just do group get, and then whatever you want. And you can actually, stack these like that. So you get your transform and mesh component. And then the cool thing is this works with C++ 17's stuff. So you can just do auto reference and then transform component. So transform, comma mesh, right? And we'll get rid of this junk, right? And by doing this, we can just get both of them immediately, and that's it. We have a reference to the transform component, it's called transform, and we have a reference to the mesh component, it's called mesh. We can do whatever we want. We can be like, renderer submit mesh transform or whatever, and that's basically our basic render loop for a 3D renderer. Done. Okay, so that's how it works. It's really simple, and really powerful and really fast and really good. So that's a rough overview of EnTT. I don't know if there's anything else that I need to cover. I'm just looking through some Hazel Dev code, but I think that that's pretty much it. Next time we'll obviously continue on with this because there's a lot more stuff to cover. But in terms of a basic introduction to Ent, I think that's about it. Keep in mind that, as I mentioned, you can, of course, chain events and like signals and stuff. So you can do registry on construct, on destroy, on replace, on update for certain for certain components. So in other words, if we construct a transform component, we can literally do .connect to like a function. So we can have a function here called on transform construct that maybe prints, hey, you constructed a transform component or whatever. I mean, realistically, you wouldn't do that, but then you just give it a pointer to that. And I think, oh, sorry, that obviously needs to be like that. And then that's it, right? So that's now going to, every time you create a transform component, this function is going to get called. And of course, I wrote this with nothing, but really it's supposed to be something that takes in a reference to the registry as well as the entity that the component was created on. So you basically end up with this. And then that way you can, of course, do other stuff in the registry if you want. You can see what entity the transform component has been created on. So many ways to do this. For example, like so many uses from this, I mean. For example, you might want to catch script events. So whenever a script component gets created, you might want to take this opportunity to like initialize or instantiate the entity inside your script runtime, now that you know that a script component has been added to it. So lots of stuff to do there and plenty of fun to be had. Anyway, I hope you guys enjoyed this video. If you did, please don't forget to hit the like button. You can also help support the development of Hazel and everything I'm doing here on YouTube by going to patreon.com/the Cherno. Huge thank you to everyone who is keeping this series going. As mentioned earlier, if you want to get access to all of this in action in like an editor inside Hazel, inside a 3D world with physics now even, then 2D physics, don't get too excited. Then check out the Patreon, and you'll also be able to get access to live streams of me developing fun stuff like this. Thank you guys for watching. Next time we're going to be probably making like an entity class of our own and seeing how that integrates with Ent and how I've been using that inside Hazel Dev as well. Thank you guys for watching. I'll see you next time. Goodbye.